Chapter 14 is going to cover solids and liquids, and it's a pretty quick chapter and it's not really in depth. Be a good review of water and the properties of water as well. So let's look at the first section called Water and its Phase Changes, 14.1. There are a lot of things you already know about water and about states of matter, such as we know the difference between gases, solids, and liquids. Gases are highly compressible. They have a very low density and they fill their container no matter what shape the container is. Solids, on the other hand, have a high density, that's mass per unit volume. They are slightly compressible, but they are rigid and tends to keep their shape. And then liquids, of course, are someplace in between. This is a picture of a water and its phase changes. So this on the bottom says heat added at a constant rate, and this is temperature in degrees Celsius. So we know that after water freezes, it can go below zero and it still remains as solid as ice. But just because we have a chunk of ice that reaches 0 degrees, it doesn't automatically all go to water, nor if we have water at 0 degrees does it automatically go to ice. So this right here is called a phase change. You'll see another phase change here between water and steam. Anything above 0 degrees, once we've taken water, liquid water, to steam, it can be heated to a higher degree, but it's still considered steam. Then we have liquid water in between those two. From 0 degrees Celsius to 100 degrees Celsius, it's liquid once it's made it past that phase change. So if we look at it this way, we're looking at a heating curve, and when we look at it the opposite direction, we're looking at a cooling curve. We know that normal boiling point of water at 1 atmosphere is 100 degrees Celsius. Normal freezing point at 1 atmosphere is 0 degrees Celsius. And we know that the density of liquid water is 1 gram per milliliter. Ice has a different density, however. Ice, or solid water, is 0.917 grams per milliliter, so it is actually less than the density of liquid water, which if we put ice in water, we would expect it, liquid water, we'd expect it to float because its density is lighter, and that is what happens. And that does contradict, let's go back and look at this, that does contradict here when we say that gases have low densities, solids have high densities. You would expect the liquid to have a density in between the two, but when it comes to water, its solid has a lower density than what the liquid does. Let's look at the concept check. During the process of melting ice by adding heat, the temperature of the ice liquid water slurry stays constant. Does it increase, does it decrease, or cannot be predicted? So the process of melting ice by adding heat, the temperature of the ice or liquid water slurry stays constant because we have it in the liquid form and in the solid form as well. And we're melting the ice by adding heat, and that's going to keep the temperature constant until it all gets to a liquid form. Let's take a look at this heating and cooling curve again before we finish up with this lecture. This heating and cooling curve is for water and its phase changes, but this can be done for any solution at all. So it doesn't necessarily have to be ice and water and liquid water. We would see this as solid, this is solid and liquid, this is liquid, this is steam and liquid, and this is steam. And we wouldn't have to be talking just about water. We could talk about any kind of solution. So if you were to ask questions or have questions asked of you about a picture similar to this one, it wouldn't necessarily have to be ice and liquid water and steam that we're talking about. So I just want to bring that to your attention. So be familiar with this for a quiz.